afternoon, class. I'm excited to have you in the class today. We have the gas laws as our concern in the class. We actually started the discussion of this topic in our last class. That's the kinetic molecular theory of matter, and by extension, the kinetic molecular theory of gases. And we agreed to dwell on gases, the gaseous states, before a consideration of the remaining two states, the solid and the liquid states. Of course, especially because of the fact that in the examination for which we are prepared, the gaseous states has the highest, by far, the highest percentage of questions. Now, we are going to discuss the gas laws, but do not forget that in our last class, we adumbrated the postulates of the kinetic molecular theory of gases, the 5 postulates. You will recall I did tell you that the English word postulate simply means assumption. So the postulates of the kinetic molecular theory are simply assumptions that have been made by scientists to explain the gaseous states, assumptions that have been made by scientists to explain the gaseous states, 5 of them. And we dwelt on interpretation of the postulates and went to the extent of considering questions only on that, especially as a result of the technical way questions on the explanations and interpretations of the postulates come. Now, today we want to dwell on the gas laws. What are the gas laws? The gas laws are laws formulated by scientists that explain the mathematical relationships between the parameters that can be used to describe the gaseous states. I want to start by asking you a very simple and interesting question. Pay attention to this question. Assume we have water, and the water is said to be at a temperature of minus 5 degrees Celsius. Water, H2O. You are told, you don't see it, that the water is said to be at a temperature of minus 5 degrees Celsius. And the question is the water solid, liquid, or gaseous? Is that water ice block? Is it liquid water, or is it vapor? What's your answer? Solid. You are correct. Why do you know that the water is solid? Because the temperature has been specified. Now, the temperature is an example of what is called a state variable. State variable, or state function. State function. You know, Friday has been declared public holiday in honor of the burial of the first lady of the state, the late wife of the state governor. So people that will be attending that burial can say, we are going on a state function. That's a state function. That is not the state function we refer to here. The state function or state variable we refer to here in thermodynamics is any parameter that can be used to describe the state of matter. Any parameter that can be used to have an idea, to gain an idea into the state or the phase of a substance. You just told me that water at minus 5 degrees Celsius is expected to be in the solid state. Did you tell me that? Yes. Simply because the temperature was specified. So if I ask you, if the water was at, say, 125 degrees Celsius, you all would have agreed that the water would be in the gaseous state. That's the vapor. Do you agree? Yes. It's not only the temperature that we need. For example, let me ask you another question. Water at, say, 80 degrees Celsius. Water at 80 degrees Celsius. 80 degrees Celsius. Solid, liquid, or gaseous? Liquid. Is that so? Good. But now let's consider that question with additional information provided. Water at 80 degrees Celsius and a pressure, atmospheric pressure of, say, 0.5 atmosphere. 0.5 atmosphere. Water is at a temperature of 80 degrees Celsius, and the atmospheric pressure condition when the water is 80 degrees Celsius is 0.5 atmosphere. Remember, the normal atmospheric pressure is 1.0 atmosphere. So if we are at a place on Earth where the pressure, the atmospheric pressure is 0.5 atmosphere, and the water is 80 degrees Celsius, as you said before when the pressure was not specified, that the water at 80 degrees Celsius would be liquid. Do you still expect it to be liquid when the temperature remains 80 degrees Celsius and the atmospheric pressure has reduced to 0.5 atmosphere? Do you still expect it to be liquid? No. What do you expect it to be? Solid or gaseous? You just say no because